Okay, so we're going to kick off our chapter 7 with how to find factors and how to find the greatest common factor of different terms. So this is something that in pre-algebra you spent a whole entire unit doing, and now we're just going to kind of briefly touch up on it, remember it, and then move on to something brand new for you guys. So let's start with just talking about factors, knowing what those mean. So I decided to give you these 3 different rectangles, and I've tried to separate them into 18 square units. I'd like you guys to try this on your own paper, and yours will probably be much better than mine, of course. But each of these can be separated into 18 square units, but done a little bit differently. So for example, this first one right here is separated into 18 square units, but it's a 1 by 18. This one is separated into a 2 by 9, and then the last one a 3 by 6. So all the same amount of area, just set up very differently. So this kind of gives you a little bit of an idea of what the heck factors are. So, oops, I've never used gray before. That's kind of cool. Alright, so these are called factors. So 1 and 18, 2 and 9, 3 and 6, those are all factors because they multiply to give you 18. Oops. I'm in a little bit of trouble today, guys. So factors are just the numbers that you can multiply together to get the term that you're trying to solve for. So when we're finding factors, you're going to find that you have prime numbers and you have composite numbers. These really came into play when we were doing factor trees. But this year we're going to graduate from factor trees and not worry too much about this, but they are important for you to know, so let's kind of just refresh on those a little bit. So prime numbers have 2 factors, and only 2 factors. Now the only 2 factors prime numbers are going to have are going to be 1 and itself. So to give you an example, oops, the number 2 is a prime number because the only 2 factors of 2 would be 1 times 2. That's it. There's no other way to get a 2. Another prime number would be 3 because the only 2 factors of 3 would be 1 times 3. Okay? So those are prime numbers. Composite numbers are every other number. So composite numbers have more than 2 factors. They could have 3 factors, 4, 10, whatever. They just have more than 2. So for example, the number 4 would be a composite number because the factors of 4 would be 1 times 4, 2 times 2. So I have these 2 factors and these 2 factors. 18 from our first example, that has much more than just 2 factors. So 18 would be a composite number. So we dealt with prime and composite a lot when we were doing factor trees, but this year I'd like you to try to stay away from those a little bit and just try to list your factors. So if I asked you to list the factors of 24, you always start with the number 1 in itself. Okay, so 24 is a composite number. There are more than 2 factors of 24. So I'm going to start with 1 and 24. Then I'm going to move to the number 2. Can I do 24 divided by 2? Yes, I can. So 2 times what will give me 24? It's going to be 12. And then I'm going to move to 3. Can I do 24 divided by 3? I sure can. So 3 times 8 is going to give me 24. And you can lean on your calculator for this. Don't feel like you have to do it all in your head. 24 divided by 4. Yep, I can do that. So 4 is a factor. So 4 times 6. 24 divided by 5, that won't work, so 5 is not a factor. It brings me back around to 6. So these are all of my factors of 24. Okay, and that's all you have to do for this section. I just want you to be familiar with the factors of each number. I'm going to have you guys try example number 2 with 84. And 105 gets a little crazy, so let's try 105. So this is one where I would even have to use my calculator for. So I'm always going to start with 1 in the number, and you're going to move to 2. So 105 divided by 2, that's not going to work. It's going to give us a decimal. So we're going to try 3. 105 divided by 3, that works. So 3 and 35 are going to be my factors. Alright, I'm going to try 105 divided by 4. I don't think that's going to work. It doesn't, so I know 5 should work because it ends in a 5. So 5 and 21. So some of these will go on for a while. 6. Hopefully you're doing this with me. 6 doesn't work. We're going to try 7. 7 works, so 7 and 15. 8 does not work. And 9 doesn't work. And 10 doesn't work. And so we can kind of assume that we're done there if we can't go any longer. And we're all the way back to 15. So these are all your factors of 105. So go ahead and try to find the factors of 84 and call me over to have that checked when you're ready. Go ahead and pause it now if you need to. And then let's move on to greatest common factor once you've gotten that checked. So when I ask you to find greatest common factor, you're going to be given 2 terms and you're going to have to find what is the biggest number that they have in common. Okay, so let's start with 30. So we're just going to list our factors of 30. So we have 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, so 5 and 6. Now, some of you might find a shortcut to this, and I hope that you do. I can kind of explain that in a minute. But if not, you can just list your factors of the first number and list your factors of the second number. So for 42, we're going to start with 1 and 42, 2 and 26, and then check 42 and 3. Does 3 work? See if it divides. So 3 and 14. And then try 4. And that doesn't work. And try 5. 5 won't work because it doesn't end in a 5. So try 6 and that works. And then we're all the way back around. So you've got all of your factors listed out. So what we're going to do is we're going to compare our list. We're going to find the biggest number that they have in common. So the biggest number they have in common is a 6. So your greatest common factor for 30 and 42 is going to be 6. So the factor they have in common is 6. Alrighty. Now have you guys try example number 5 and call me over when you've got that. Pause it if you need to. And then sometimes you might see, excuse me, you might see some, me ask you greatest common factor with variables. So let's try, I'm going to show you the shortcut with this one. So 2 is my only number. 2 is a prime number, I'm sorry. So the only number that is a factor of 2 would be 1 times 2. So obviously, if that's the only thing I can do, I'm going to see if 2 can divide by 6 and 16, and it can. So I automatically know that my greatest common factor is going to be 2 for these 3 numbers. However, I've got these weird variables. So when I'm asked to find the greatest common factor of variables, I'm just going to take the smallest exponent that I see. So x to the first. They all have an x to the first in common. You can fit an x to the first in each of these. So my greatest common factor is going to be x to the first. Okay? So the GCF with variables is always the smallest exponent that you see. Alright? I'm going to have you guys try example number 7 and then call me over once you've got that so I can check it. Okay? Now, there's a lot of information today. But just try your best and understand that you guys have done this before and it's just a little refresher. All right.